Today's notes are brought to you by inspirational quotes like this. You can never cross the ocean unless you have the courage to lose sight of the shore. And I hope those words of inspiration help you as you write your title for your notes. On the right-hand side, the title is Simplifying Complex Fractions, which will go right here. Go ahead and split up your note into thirds, and the bottom 2/3 you're going to split into 4 equal boxes, listed example 1, 2, 3, and 4. So what is the big idea of complex fractions? Well, here's what a complex fraction looks like. A complex fraction is a fraction within a fraction. So an example of that might look like this. Maybe 2x minus 5 over 3x squared plus 4 divided by 2 over 5 plus 3 over x squared. So what makes it complex is that there's a fraction in the numerator and maybe a couple other fractions too in the denominator. It doesn't have to be 1, it could be 2. So here's the big idea that I want you to keep in mind. I'm going to put this in purple. The big idea is, how do you rewrite something like this into something that you know already? So here's the idea. Let's say you have a over b divided by c over d. And I want you to imagine that a and b and c and d are really ugly polynomials. This can be rewritten and is equal to a different a form that you're more familiar with. And it looks like this. A over b divided by, and this division sign is coming from here, divided by c over d. And this is something that you're really familiar with. Okay, so let's start with example 1. Go ahead and copy this example and make sure you have your marker ready. When you see me change to the red marker, please take out your marker. So the first thing I'm going to notice is that this is a complex fraction. It's a fraction divided by another fraction. So the first thing I'm going to do is rewrite it. I'm going to take my first fraction, and then I'm going to take this division line. Instead of writing divide like that, I'm going to write it like this. And then the second fraction is x squared minus 9 divided by 21. From this point, you can probably fast forward the video and go straight to your answer because you know what to do, but just in case, I'm going to revisit how you do this problem. So since this is a division problem, I'm going to keep my first fraction the same. I'm going to change division to multiplication, and I'm going to do the reciprocal of this fraction here. So I'm going to write 21 over x squared minus 9. My second step is to ask if I can factor anything. X plus 9 can't be factored. 21 is 7 times 3. My denominator 7 can't be factored. And x squared minus 9 is x plus 3 times x minus 3. So now I'm going to look to see if there are any factors of 1. But before I do that, I have to check for my excluded values. X cannot equal. When I look inside my parentheses, I'm going to ask myself what value of x would make this whole value equal 0. That's negative 3. And when I look in my second, what value for x would make this whole parenthesis 0? That's positive 3. Now I can cancel out my factors of 1. Now I'm looking and looking. I really only see one factor of 1 that I can cancel out, which means now I can go straight to my answer. My numerator has a 3 and an x plus 9 multiplying, and my denominator, x plus 3 and x minus 3. And this is my final answer. So again, for this problem, the first thing I notice is that I have two fractions. So this is a complex fraction, so I'm going to start off by rewriting it. I'm going to take my first fraction divided by x squared minus 9. And I'm going to need a little bit more space. I'm going to zoom down a little bit. And instead of writing this division bar as a fraction bar, I'm going to write it as the symbol division. And take my second fraction, x plus 2 over x minus 3. Now this is a division problem, so I know the first thing I need to do is change division to multiplication, and then I need to flip these to the reciprocal, which will now be x minus 3 over x plus 2. Now I'm going to put these on one term, and I have this guy, x squared minus x minus 6 multiplying across times x minus 3. and I have x squared minus 9 times x plus 2 in the denominator. Now at this point I need to ask myself, can I factor any of those parts? Well, the first thing I look at is this section right here. Can I factor x squared minus x minus 6? What multiplies to negative 6 and adds to negative 1? I'm going to do that little math over here. You can do that too if you want. I'm going to say negative 3 and 2, so that's x minus 3 times x plus 2. Can x minus 3 be simplified? Can it be factored? Nope. That's going to stay the same. Can x squared minus 9 be factored? Well, it's a difference of squares. X minus 3 and x plus 3. And can x plus 2 be factored? Nah. There it is right there. At this point I should easily be able to see my excluded values looking at my denominator. What values here, here, and here would make 0? And I hope you say 3, negative 3, and negative 2. That means x does not equal 3, negative 3, or negative 2. And when I look at my factors of 1, I can factor out that factor of 1 and this factor of 1. That means my final answer is x minus 3 over x plus 3, and my excluded values are 3, negative 3, and negative 2. Okay, now this problem looks a little bit different because now we have two fractions in the numerator, which automatically I'm going to have to do a little bit of work up here before I can rewrite it. So what I'm going to do is I'm going to take this and I'm going to think about it down here. So I have x over 2 plus 2 over 2. Now when I look at these fractions, even though I know there's an x here, I know that you can add fractions if they have the same denominator. Now, these do. So just the way you would add any fractions. The denominators are the same, so my answer will have the same denominator. And now I'm going to add x plus 2. Can I add x plus 2? No, but I could write it like this, x plus 2. So what if I take this and I rewrite my complex fraction? Maybe now I can rewrite it. Okay, here's my new problem. So instead of writing this, I'm going to write my new sum, which will take its place. Now I can rewrite it. This is x plus 2 divided by 2 divided by 2x plus 4 divided by x squared minus 2x minus 3. Now I'm going to scroll up and let's do this problem. Of course, the first thing I'm going to do is rewrite this from division to multiplication, and I'm going to do the reciprocal of my second fraction. All I did is flip these two. Now I'm going to put these on one fraction. So I have x plus 2 times x squared minus 2x minus 3. I'm just multiplying across. And I'm going to ask myself, can I factor these parts? Can I factor x plus 2? Can I factor x squared minus 2x minus 3? Can I factor 2? Can I factor 2x plus 4? And the answer is no, I can't factor x plus 2. But I sure can factor this guy over here. So on my sidebar I'm going to ask myself what multiplies to negative 3 and adds to negative 2? How about negative 3 and 1? So when I factor that, I'll get x minus 3 times x plus 1. My denominator, 2, I know can't be factored. But I really want you to take a close look at this binomial. It's certainly not a difference of squares, but it is a GCF. And what can I take out of there? I can take out a 2. And what multiplies times 2 to give me 2x? That's x. And what multiplies times 2 to give me 4? That's 2. Now from here, you should be able to find your excluded values. There's only one. What number plus 2 would give me 0? That's negative 2. Now my factors of 1, I hope you can see, are x plus 2. And that means that my final answer has an x minus 3 and an x plus 1 in the numerator. And what's 2 times 2? Yeah, that's 4. This is the answer to this really what looked like a kind of a really unattractive problem. Our answer to all of this was just x minus 3 times x plus 1 divided by 4. For this last problem, I'm only going to take you to the first step. So the first thing I notice is this is a complex fraction, one fraction over the other. So I'm going to start by rewriting it. Divided by x squared minus 4x minus 21 divided by x squared minus x minus 2 divided by x squared minus 8x plus 7. Now I helped you rewrite it, and I'd like you to finish it. When I check your notes, I'd like to see this problem completed. When you finish, check with your neighbor and see if they got the same answer.